What's going on, everybody? I'm Johnny Brook. Welcome back to another Crafted Workshop video, and welcome back to my new, I guess, kind of old shop. So in this week's video, I'm going to show you guys how we installed all of this steel support material here in the walls. But before we dive into the work, I just want to talk about why we're doing this and kind of the plan, just in case you guys are new to the series. So rewind to when I bought the building, there were some clear structural issues with both of these concrete block walls, and the previous owners had, I think, tried to fix things with these big diagonal supports that were here previously, but that didn't really seem to be doing a whole lot. So I got in touch with a structural engineer who came up with a plan to kind of fix everything, and it was a multi-step plan. So step one was dropping the floor joists in the back corner of the shop. You guys saw me do that with the Perkins crew. Dropping those joists back down helped to support the top of that wall section, and it also gave us a continuous area to attach these new walls to, since we could attach the top plates to those floor joists. So step two was to build all of these stud walls. We used 2x6s. They were built extremely strongly. They've got joist hangers at both the bottom plate and top plate. They're attached to the floor with these giant 3/4 inch wedge anchor bolts, which you'll see later in this video. They're super sturdy, but the main reason for building them out of 2x6s was so we could fit these 5-inch wide C5 by 6.7 is what they're called, steel C-channel pieces in the wall cavities. And these steel pieces are really what's adding a lot of the structural support to this wall. And in this video, I'll show you how we welded up the supports, got them installed, and basically wrapped up the structural work on this part of the shop build series. So now that you guys know why we did the steel, let's go ahead and jump in and show you how we did it.
I got started on the process of installing the structural steel by laying out where exactly the pieces would need to be installed in the walls. And the structural engineer I worked with called for adding this steel C-channel at 4 foot on center increments along both exterior walls, and I marked the stud locations with red spray paint for easy identification. The engineer also noted I could skip the steel anywhere I was planning to build an adjoining wall, like the CNC room for instance, since the interior walls would give the exterior walls a similar amount of support as the steel once they were sheathed with 1/2-inch plywood. In addition to the CNC room, I decided to build an enclosure for my dust collector, which will both help to deaden its very loud sound, but also provide more wall support so I can skip the steel in this section of the wall as well. And this steel was extremely expensive at about $108 per 20-foot stick. And in total, I needed 18 of those 20-foot sticks for a grand total of more than $2,000 in steel C-channel after tax. Anyway, after laying out the steel locations, we needed to come back and add blocking above where the steel would be installed in this right wall. And the steel would be attached to the floor system above with 6-inch lag screws, and without this blocking, the steel would only have been attached to the top plates instead of being tied into the entire second level floor system.
Hey, what Jason's trying to do up there is center the block, but he can't really see what he's doing.
Hey, Eric.
I'm gonna narrate. So he's getting really ticked in his head right now, and he's gonna ask us to move the scaffolding up or down again.
Installing this blocking was a little awkward to say the least, and big thanks to the Ray J Builder Buddies for knocking this out. We needed a double layer of 2x10 blocking at each of these support locations, and this was a super time-consuming process. While the Ray J guys worked on the blocking, Eric and I worked on getting these massive 3/4 inch wedge anchor bolts installed, and these bolts will provide an extremely strong connection between the bottom plate and the slab, and I installed them at a 2 foot on center spacing as specified by the engineer. From there, we just kept working our way down the wall and called it a wrap on this prep day once the blocking work was done. A few weeks later, once I had bought the huge pile of steel C-channel, we could get started on fabricating and installing these steel supports. We got started by cutting the 3-inch long pieces of 3-inch angle iron, and these would be turned into the mounting brackets for the steel supports. And the engineer specified 5/16 inch thick angle iron, but all I could find locally was 3/8 inch material, so these were some extremely beefy brackets. And thankfully, this cold cut saw made quick work of cutting this thick steel, and I'll link to this specific saw in the video description in case you're interested. While Jason worked on cutting the brackets, Ray worked on drilling the holes for the lag screws, which will attach the top of the supports to the floor system. And the engineer called for 2 lag screws at the top of each steel support, so these brackets needed 2 holes. We set up a drill press vise so Ray could just rotate the bracket 180 degrees to get a perfectly offset hole spacing, and this kind of setup made it much quicker to drill the holes in the 36 mounting brackets. To mount the steel supports to the slab, the engineer specified more of those 3/4 inch wedge anchor bolts, so we needed to switch to a larger hole saw for these holes. And we only needed 1 hole per bracket on these bottom brackets. While the guys worked on getting the steel prepped, I worked on getting my trusty Lincoln Electric PowerMig 210MP welder set up. For the wire on this job, I went with Lincoln's Outer Shield 71M, which is a dual shield flux core wire, meaning the puddle is protected by both shielding gas and the slag formed during the welding process. And dual shield flux core is ideal for this kind of structural steel work, as you typically get really good penetration and can lay in a lot of filler material very quickly. My buddy JD from Apex Welding is a big fan of dual shield for this type of structural work, and he gave me a bunch of tips on working with dual shield, so big shout out to him. So to switch from solid core MIG, which is what I usually use, to dual shield, I first removed the solid core wire off camera, installed a knurled drive roll, and then fed in the new wire. And I also changed the contact tip on my torch to match the 0.35 diameter of the dual shield wire. Once that was done, I could get the machine settings dialed in, and you need to use the manual CV mode on this PowerMig machine for this type of welding, since they don't have a dedicated dual shield flux core mode. And I started with the settings at 300 inches per minute of wire feed speed and a voltage setting of 21 volts, and then Jamie and I could start doing some welding. And the first couple of welds were looking pretty good with these settings, but we bumped up the wire feed and voltage just a bit, as it seemed like we could push the speed a little more, and this helped a lot. And we ended up at around 330 inches per minute and 23 volts, and this seemed to be a pretty good sweet spot for this combination of steel. So as you can see, this dual shield flux core puts off a ton of fumes, so we got my Lincoln fume extractor running to help protect our lungs. And one tip when using a fume extractor like this is to not put it too close to your gun, as it can actually suck away your shielding gas, which can lead to porosity in your welds. The welding work was going super smoothly, and we could tell we were getting the metal nice and hot with good penetration, as we could actually see the glow of the puddle through the underside of the material, showing that the pieces were really fusing together nicely. Since this dual shield wire leaves a layer of slag on the finished weld bead, we needed to remove the slag with a chipping hammer between passes, and thankfully it came off super easy most of the time, and the underlying welds were looking pretty darn good. Once the slag was knocked off, we hit the welds with a wire brush just to clean them up a bit, and then it was really just rinse and repeat. And Jamie and I really got into a groove welding, and it was super fun getting back to it after over a year of being away from welding, and we just traded off between welding and running the fume extractor. And we might have gotten a little carried away in our conversation as this happened.
Wait.
Dude, you got one job, dude. Hey,
Jason's trying welding for the first time, and look what he's doing.
I didn't do that. This guy did.
Dude, right. When you drill the holes next time, you're supposed to drill them on this side of the
really funny,
It's hot. Don't touch it.
both Jamie and I welded on this. We traded off. We're standing here just looking at it.
Hey, you want to know why?
Remember what I said at lunch? Yeah. What I said at lunch?
Well, we were talking about our vasectomies.
Yeah, we're just comparing vasectomy notes.
Yeah.
You know.
So, yeah.
I think John.
Oh, gosh.
One job.
Anyway, once we got a few supports welded up, Nate got to work priming the pieces with rusty metal primer. And this will keep the supports from rusting over the years, and was another detail spec'd by the engineer. Also, you can see just how much heat we were putting into these pieces, as the primer was sizzling even after giving the supports about 15 minutes to cool down. It's pretty crazy. Another detail to figure out was a method for labeling these supports, as each piece of C-channel was cut to length to fit in the wall sections, since we built these walls in place, so we needed to keep these pieces of steel organized. Of course, the Sharpie would be covered up by the primer, so we figured the easiest way to quickly label the parts was to just weld the number right onto the face of the C-channel. And as you can see, this worked great, and the numbers were easily visible even after painting. Once the primer had a chance to dry, we could get to work installing the supports in the wall, and this required a little persuasion in a few spots. And thankfully, we cut the pieces about a 1/4 inch short just to give ourselves a little wiggle room, but they were still tight in a few spots. To install the supports, the guys first got the support butted tight up to the block wall towards the center of the support, so the steel would brace the concrete block, which was the whole point of installing it, and then they roughly leveled the support, making sure it wasn't proud of the 2x6 framing. Once the piece was in position, they could get the hole drilled in the slab, and I pulled out my monster of an SDS drill for this since we had so many holes to drill. After drilling, they vacuumed out the hole and then pounded in the wedge anchor before finally tightening it down with an impact wrench. At the ceiling, Ray pre-drilled holes for the lag screws and then drove in the screws with another impact wrench, and the screws landed on a joist or ladder blocking on this back wall. And between the 2 lag screws and the wedge anchor bolt, these steel supports definitely are not going anywhere, and I'm guessing we could remove the concrete block walls completely at this point if we wanted to. The Perkins guys kept chugging along installing the steel while Jamie and I kept welding, and we got the entire back wall and the first part of the side wall knocked out on this first day of steel work, which is nuts. And once again, I always underestimate just how much work we can get done when the Perkins crew shows up, and big thanks to them for continuing to help out on this project. And if you haven't already, make sure to go subscribe to the Perkins Builder Brothers and the Ray J Builder Buddies. Both of their channels are great.
All right guys, so as you can see, the steel is in. This was a huge relief to get this done. I honestly had no idea how long it was gonna take. And with the Perkins guys, we got it done in about 2 days if you include the blocking work. So that's awesome. And that means that all of the structural work as part of this kind of shop renovation, at least here in the shop area, is done. So that means we can move on to getting the space a lot more finished out. So the next step in this process is gonna be getting some insulation added, obviously. I had all the ceiling insulation removed previously because it was in pretty bad shape. And so I got a quote on the new insulation and it's gonna be over $10,000. So that hurts a little bit for sure, I'm not gonna lie. But you know, I obviously wanna do this right because once these walls and the ceilings are closed up, I really don't wanna have to go back in the future and redo that. For now, I need to get prepped for having the insulation installed. And that means removing all of this old electrical from the ceilings here, because obviously it's gonna be a lot easier to remove that stuff without insulation in my way. As I've mentioned, I'm pretty much gutting the electrical in the shop space. It's very dated. None of the outlets were grounded. A lot of it was kind of messed up by the previous owner. There's a lot of kind of rat's nest of wiring in some of these junction boxes. So I'm just gonna start from scratch, and that way I can run outlets exactly where I want them, because obviously all my tools are gonna need specific outlets for where they're gonna go, and none of that would have been here already. I'm also gonna pull down this old fluorescent lighting, which has added a lot of terrible color and flicker to these videos. So hopefully the quality will be getting better here, because I'm gonna put up some more of these big high bay lights. These are gonna be temporary lighting. I'm gonna go with American green lights for the final lighting, but these have been great in the interim. They just plug in and are super, super bright. And I've got these reflectors on them, which help to really spread out the light. And I think they look pretty decent and are great to work under because they're really bright. So if you need some kind of temporary job site lighting, or really if you just have a large space like this, they're a pretty good option because, again, they just plug in, so they're super simple. So I guess let's go ahead and get to demoing the electrical. This is not the most fun thing in the world. Definitely gonna get covered in dust, but it's gotta be done. So let's get to work.
So the first step when working on electrical is making sure you're not going to get shocked, so I went ahead and killed the power to the sub panel, which powers most of the circuits in the main shop area. I also double checked the sub panel with a multimeter just to make sure I wasn't going to zap myself while working in the open panel. Now that I was going to be removing the fluorescent lights, I could finally get rid of the extension cord running to the open junction box, courtesy of the previous owner, which had been powering these lights. Next, I started removing some of the disconnect boxes and junction boxes, and again, I just double checked everything with a voltage tester just to be sure the power was off, since there is another sub panel that powers a few of these circuits. And I'm gonna hang on to these boxes as I can probably reuse some of them when I rewire the shop in the future. Once the boxes were removed, I started taking the conduit apart, and once again, I'll be saving some of this conduit to reuse later, and any of the pieces with lots of bins will be thrown out, but I've probably still salvaged a few $100 of conduit while taking all this stuff apart. Once I had most of the conduit run disassembled for each circuit, I could trace the wires back to the panel and get them disconnected so I could pull the wire. And my plan is to recycle all this copper, and with the current price of copper, this should hopefully cover a lot of the costs of the new wire that I'll need. From there, I just continued pulling down conduit and tracing the wires back to the panel, and I pulled a ton of wire out of these runs. And a lot of these were for 3-phase outlets, so there were typically 4 or even 5 wires in each run of conduit. I also pulled down anything else that would get in the way of the insulation installers, including the old PVC air lines, and I wrapped up the day by getting this big run of wires pulled out back to the other sub panel in this addition.
Well, it is fairly dusty work here. It was pretty dusty. You can see it is it's time to take a shower, but got really good progress made. Pretty much pulled out all of the conduit and electrical and fluorescents in the main shop area, but I will need to do a little bit more work in the addition kind of hallway area. So I'll come back tomorrow and wrap up the addition area.
So I'm just gonna go like, say there.
I mean, what's the problem? I don't really,
Yeah, it looks fine. I mean,
just good airflow.
if I was a snake though, and I saw that, I'd probably want to crawl right into your shop.
That's exactly what happened.
Exactly.
And so that gutter nail, that was the culprit, you think?
I think so. Basically, on the other side, there's a hole just like this, but the wood is so rotten that the nail won't stay, so it's just coming out, and so when the gutter fills up or water runs in the gutter, I think it's just running right through that hole and down into your snake entrance. I think we can fix it.
All right.
Oh, that was as crooked as could be. Try again. There we go.
Hey, want to hear the most annoying sound in the world?
The key to this project being a success is me not cutting through the backside of your gutter on the inside here and making the situation worse. But I think I can use the blade itself to tell me when to stop. So it's right at that little logo there. Get out of here, babe. I feel like the whole face of the board is rotten. It's just going.
Yeah.
So for any viewers wondering how we're filming this, like, he's not floating. We're both standing on the same ladder really close together.
Dueling ladders.
So
Trying to fight off this carpenter bee.
this is a good ladder for that though.
Oh yeah. I think you could just blow on it and come out. Jeez.
There we go.
Wow. Slightly rotten. Jeez. Nasty.
Yeah. So, oh yeah, look at the face right here. There's that much of that left.
Wow.
I hear that bee again. You look good out there? I'm all good in here, so I'm gonna scab it in. Ooh, there's that bee.
Jeez.
Leaves taste.
Free fiber, bud.
Good.
All right, so I think you guys can just kind of see the replaced section of soffit here, but with that done, we're pretty much ready for insulation here in the new shop. One kicker though is that the insulation guys are 3 to 4 weeks out, so we're gonna have to kind of pause this series for the time being. That works out though because I need to finish the not so tiny house. A lot of you guys have been asking about it. It is not done. It's been kind of waiting on the work to be done here at the shop, so next week's video will be on the not so tiny house. So hopefully you guys will go ahead and get subscribed and ring that notification bell so you don't miss that video. Also, as always, I'll have links to all the tools and materials I used in this video down in the video description below. And last, if you want to support me and help pay for the $10,000 of insulation, I sell merch. I've got plans for a lot of my woodworking projects, and I have both Patreon and YouTube members set up. All right, thanks for watching, y'all, and until next week, happy building.